पानी देगा जरा श्यामल। Hello everyone. Hello Chandrakant. In today's lecture, we are going to see acceleration analysis in dynamics. In previous lecture, we have seen velocity analysis. Here, for the same problem, we have seen velocity analysis in previous lecture. In this lecture, we are going to see acceleration analysis. Now, see, in GATE examination, the same question, the similar pattern of question they have asked at least for 5 to 6 times, right? And at the end of lecture or probably next lecture, we are going to see all the previous year GATE questions, but with the help of this question, you will be able to solve each and every previous year GATE question as well as previous year any competitive exam question, right? In this lecture, we are going to see for plane motion acceleration analysis. Plane motion is nothing but linear motion plus rotational motion together is called plane motion. Now here in this numerical question is a wheel of radius 2 meter. Here radius of wheel is given 2 meter, rolls freely as shown in figure. See here, this wheel rolls freely on the surface. Let us say here this is a ground, right? On this ground, wheel is rolling, right? Rolling means while rotating, this wheel is rotating with angular velocity omega, angular acceleration alpha. The wheel is rotating with angular velocity omega with angular acceleration alpha, and while rotating, wheel will go forward like vehicle wheel, your four-wheeler wheel, like this, right? The wheel is also moving in forward direction. This will be the motion along with rotation, right? There is a linear motion with rotation also. Now, if velocity and acceleration of point A is 6 meter per second and 20 meter per second square, here point A is the center of wheel. Point A is the center of wheel. For this center point, velocity is 6 meter per second and acceleration is 20 meter per second square. Then find acceleration of other points shown. Now here we have to find acceleration of point B, C, D, and E. Right. Now the given data is radius of wheel is given 2 meter. Right. Then velocity of center point, that is velocity of center point A point, is given 6 meter per second, and acceleration of A point is 20 meter per second square. This is a given data, right? And question is to find acceleration. See, my dear students, in previous lecture already we have calculated velocity of point B, point C, point D, and point E. For velocity analysis, you can watch my previous lecture, that is dynamics plane motion. You can type dynamics plane motion Ekeeda. You will find this lecture on YouTube, right? Now in this lecture we are going to see acceleration analysis only. Here we are not doing velocity analysis because already this chapter is, we have seen this chapter, velocity analysis. Now finding acceleration of B point, C point, D point, and E point is a question. Now my dear students, not only 4 points, we can find infinite points. We can find for infinite points velocity, acceleration, all the analysis, right? Good evening. Pandurangam, good evening. Okay, let us jump to the question. Okay, now A is a center point. Point A is a center point, and this A is having velocity 6 meter per second and acceleration 20 meter per second square. Now we know that velocity of center point is nothing but r omega, that is radius of wheel into angular velocity, that already we have seen, right? Therefore 6 is equal to radius of wheel is 2 into omega. Therefore, angular velocity of wheel will be 6 divided by 2, which is nothing but 3 rad per second. That we have calculated. Angular velocity of wheel is 3 rad per second. As well as we know that the acceleration of center point, that is acceleration of A, is nothing but radius of wheel into angular acceleration r alpha, that already we have seen in previous lecture, right? And you must know this, because this lecture we are not going to study concepts. In this lecture we are going to solve only numericals, right? Here I am assuming that you have seen theory lectures from Ekeeda application, from engineering mechanics, dynamics, all the topics, and we are directly solving here questions, previous year gate question, previous year competitive exam question. And my dear students, each and every question they have asked in gate examination. Here velocity of point B, acceleration of point B, velocity of point C, acceleration of point C, velocity acceleration of point D, velocity acceleration of point E. Each and every question they have asked in previous year gate examination, right? In previous lecture we have seen velocity analysis. Here we are going to see acceleration analysis, right? Now acceleration of center point is r alpha, that we have seen. Therefore acceleration of A is 20 is equal to radius of wheel is 2 into alpha. Therefore angular acceleration alpha will be equal to 20 divided by 2, which is nothing but 10 rad per second. So my dear students, in this question we have calculated angular acceleration, which is 10 rad per second, and angular velocity 3 rad per second. Sorry, angular acceleration is 10 rad per second square. Acceleration unit is rad per second square, right? And angular velocity 3 rad per second, that we have calculated. Now let us use this data, right, and solve this question. Now my dear students, therefore radius of wheel is given 2 meter. We have calculated angular acceleration, angular velocity as 3 rad per second. Also we have calculated angular acceleration as 10 rad per second square, right? Then velocity of center point is given 6 meter per second, and acceleration of center point is given 20 meter per second square, right? This is a given data. And the wheel, you can see the wheel is like this, right? Here you'll see this is a wheel, and A is the center point of wheel, right? The wheel is rolling over the ground. The wheel is rolling over the ground, and point of contact between wheel and ground is C. Then there is a B point. Right extreme point is B point. Then the south extreme point, that is the below point, right, is C point. Then left extreme point is D point. Then top extreme point, that is north extreme point, is E point. These are the points, and we have to find acceleration of each point. Now my dear students, this wheel is rotating with angular velocity omega and angular acceleration alpha, as well as this, while rotation, this wheel is moving in forward direction, means it is a combination of linear plus rotational motion. The problem is a combination of linear plus rotational motion, right? Now therefore we have seen for each and every point on the circumference or at any other location from the center, there will be a centripetal acceleration, there will be a radial acceleration. That is, acceleration of any other point P is equal to acceleration of A plus acceleration of that point with respect to center point, right? Acceleration of any other point P is equal to acceleration of A. It is a vector sum, my dear students. It is a vector addition. That is, this addition will follow law of parallelogram. For this addition we have to follow law of parallelogram, and on law of parallelogram we have seen the first live lecture of engineering mechanics, we have taken on law of parallelogram, right? Now this is a vector addition, that is law of parallelogram will be used for the addition, right? And this acceleration of any other point with respect to that point is having two components. It is having two components. One is tangential component and other is centripetal component, or also called radial component, right? Acceleration of any other point with respect to center point will be having two components, that is one tangential component and other is centripetal acceleration or radial acceleration. This is AT is called tangential acceleration, tangential acceleration, and it will be tangential in the direction of rotation, in the direction of rotation, right? Tangential acceleration will be tangential in the direction of rotation, and this AT is given as R center point to P, that is distance. This tangential acceleration is given as distance of point P from center point into alpha, R alpha. This is how we can calculate the tangential acceleration and in the direction of tangent. And acceleration AC, AC is also called, this AC is also called centripetal acceleration, centripetal acceleration, and this is towards center along radius, towards center along radius that we have seen, right? Centripetal acceleration is towards center along radius. Centripetal acceleration is also called radial acceleration, and this centripetal radial acceleration, also called radial acceleration AR, also called radial acceleration AR, or centripetal acceleration AC, is given as for R A to P, that is distance of center from the point P into omega square, R omega square, R omega square. This is how we can calculate centripetal acceleration. But here RAP is distance between point A and P, and P is any point. It may be a point B, point C, point D, point E. Right. Now let us find them. We will first find tangential acceleration and centripetal acceleration for each and every point. My dear students, can you see here? The distance of point B from A is radius of wheel, as well as distance of point C from A is radius of wheel. Distance of point D from A is radius of wheel, as well as distance of point E from the A center is radius of wheel. Means each and every point, that is point B, point C, point D, point E, are at same distance from the A point, right? Therefore, now let us find these accelerations. Here we are going to find accelerations, that is tangential acceleration. Can you say this? That is distance between A and B is equal to distance between B and C, sorry, A and C is equal to distance between AD is equal to distance between AE is equal to radius of wheel, which is nothing but 2 meter, that we can say, right? Therefore, tangential acceleration at each and every point, tangential acceleration, which is nothing but radius R into alpha, therefore will be equal to R alpha, capital R alpha, right? Because for each and every point the R is at same distance, right? Which is nothing but R is 2, alpha is 10. Therefore tangential acceleration for each and every point will be equal to 20 meter per second square. This will be your tangential acceleration for B as well as C as well as D as well as E point, right? Then radial acceleration or centripetal acceleration. Radial acceleration or centripetal acceleration is equal to R omega square. Now here small r is nothing but RAB or RAC or RAD or RAE, which is nothing but capital R. Therefore it is R omega square, right? Therefore centripetal acceleration is equal to 2 into omega is 3 square, which is nothing but 18 meter per second square. That we have calculated centripetal acceleration, right, which is nothing but 18 meter per second square. So my dear students, here I will write these two accelerations. I will write here, right, that is tangential acceleration and centripetal acceleration. Here, therefore, for point A, B, for point B, C, D as well as E, tangential acceleration is 20 meter per second square and centripetal acceleration is 18 meter per second square, right. Now let us find the accelerations. That is, if I want to find acceleration of point B, it is nothing but acceleration of A plus tangential acceleration plus centripetal acceleration, right. If I want to find acceleration of B, then it is acceleration of center point plus tangential acceleration plus centripetal acceleration. Now this A will remain as it is. AT is in the direction of rotation tangential. AT is tangential in the direction of rotation, and AC is towards center along radius. AC is towards center along radius, which is centripetal acceleration. Now let us find for each and every point. Now if I want to find for point B, first of all, let us say point B. I will consider point B. And for point B, we are going to find acceleration, total acceleration, right. Now my dear students, with respect to A, consider point B. Here you can see, if I draw one wheel, let us say this is a wheel, right. For this wheel, center point is A point, and center point is A point, which is moving with acceleration of A, which is moving with acceleration of A, right, towards right, right. Acceleration of A is given towards right, right, definitely. Therefore the B point is lying here. Therefore this point B, and also wheel is rotating in clockwise direction, right. Wheel is rotating in clockwise direction with angular velocity omega, angular acceleration alpha, right. Now point B will be here. Now for this point B, you can see here, for this point B, acceleration of A will remain as it is, plus there will be a tangential acceleration in the direction of tangent and centripetal acceleration towards center along radius. So for B, acceleration of A will remain as it is. There is a acceleration of A, which is nothing but 20 meter per second square, right. Then there will be a tangential acceleration, and tangential acceleration in the direction of rotation. See, point B is moving in downward direction with respect to A. With respect to A, because of this clockwise rotation, here you can imagine, because of this clockwise rotation, right, because of this clockwise rotation, this point B, you can see it is going in downward direction. It is going in downward direction, and at the instant of B, the tangent is always perpendicular to radius and going in downward direction. Therefore perpendicular to radius, here we can see perpendicular to radius in downward direction, there will be a tangential acceleration, which is nothing but 20 meter per second square, which is nothing but 20 meter per second square. And radial acceleration is, or centripetal acceleration is towards center along radius. Therefore towards center along radius at point B, towards center along radius, there will be a centripetal acceleration like this. There will be a centripetal acceleration AC, which is nothing but 18. Centripetal acceleration is having magnitude 18, right, 18 meter per second square. Therefore if I consider point B, my dear students, let us consider this point B. Here there is a point B, right, here there is a point B. This point B is moving with acceleration of A towards right, which is nothing but 20. Also this point B is moving with acceleration of tangential acceleration in downward direction with 20, and also moving towards left with centripetal acceleration of 18. Now we have to find the resultant of these three accelerations. So let us find resultant of these three accelerations, right. Now here I am erasing this diagram. Let us find this resultant. Now my dear students, can you see here, From this a 20 meter per second square, this 18 will get cancelled because they are in line. This 20 acceleration of a towards right and acceleration ac centripetal acceleration towards left, they are in line. Therefore from this 20, 18 will get cancelled and the resultant will become like this. The b point will move with 20 minus 18, which is nothing but 2 meter per second square towards right, that is 20 minus 18, and downward direction there will be a 20. In downward direction there will be 20 meter per second square, right? These are the two accelerations for b. Now we have to find resultant of these two accelerations. Angle between them is 90 degree. Angle between them is 90 degree. Therefore the resultant acceleration of b will be like this. Now इन दोनों का रिजल्टेंट निकालना है दोस्तों. Therefore इन दोनों का रिजल्टेंट दोनों के बीच में आएगा. That is, this will be your acceleration of b, right? And which is nothing but under root of, for two perpendiculars, resultant is under root of 2 square plus 20 square. बराबर है कि नहीं? रिजल्टेंट कैसे निकालते हो? लॉ ऑफ पैरेललोग्राम और पाइथागोरस थ्योरम. और पाइथागोरस थ्योरम फॉर टू परपेंडिकुलर वेक्टर्स, द रिजल्टेंट इज under root of square of first plus square of second. Now solve this. Whatever may be your answer, I don't know answer. My dear students, I don't know answer. This will be the direction of b. Here direction is represented by arrow. Direction is represented by arrow and magnitude is given here. Under root of 2 square plus 20 square, which will be acceleration of b will be equal to under root of 2 square is 4, 20 square is 400, right? 404. The answer is under root of 404 and unit will be meter per second square. Unit will be meter per second square, right? Whatever may be the answer, you have to find. I am not going to resolve this. आपको अंडर रूट आना, आप अंडर रूट तो कैलकुलेट कर सकते हो कैलकुलेटर में, उतना तो कर लो, right? Anybody having any doubt, then you can ask me. अगर किसी भी प्रकार का डाउट है तो मुझे पूछो बच्चों. For any kind of doubt, the comment box is always available because this is very much important topic, hot topic है ये. They are asking many questions on this topic, right? Okay, if no doubt, let us go for acceleration of c. If no doubt, we will jump to find acceleration of point c, right? Now my dear students, no doubt na? Okay, let us jump on to finding acceleration of point c. चलो acceleration of point c निकालते हैं. Now my dear students, point c, in previous lecture we have seen point c is a instantaneous center. Point c is a instantaneous center, right? If you are mechanical student, you are going to learn this concept in theory of machine, right? Theory of machine में भी पढ़ने वाले हो इस concept को. But if you are civil student, learn here, right? Previous lecture में मैंने बताया था instantaneous center क्यों बोलते हैं, because the velocity of point c is 0. For this you have to go in previous lecture. What you have to type plane motion dynamics, plane motion Ekeeda. इतना भी YouTube पे टाइप किया तो मेरा लेक्चर आ जाएगा, उसमें मैंने बताया सब कुछ है, velocity of c कैलकुलेट करके बताया. Now if velocity of any point is 0, then that point is called instantaneous center, right? Here point c is instantaneous center. The velocity of instant center is 0, but instant center is always having acceleration. अब वो कौन सा acceleration होता है, यही पे याद रखो, बहुत बार गेट में 2-3 बार पूछा है. What is the acceleration of point c? ये 2-3 बार पूछा है और बच्चे क्या करते हैं, कैलकुलेट करते बैठते हैं. Students are going to calculate. They are calculating acceleration of center point, that is c. Instant center पे क्या आएगा, acceleration of point c will be equal to acceleration of center point plus tangential acceleration plus centripetal acceleration. इतना सब कुछ आएगा ना at x, that is, see my dear students, AC is acceleration of C point, and here this AC, instead of this AC I will write AR, so that you will get clear idea. Radial acceleration, here you have to make correction AR. करेक्शन नहीं है ये, सेंट्रीपिटल एक्सेलरेशन भी बोलते हैं उसी को हम, राइट। लेकिन जैसे कि पॉइंट सी आया ना, तो एसी में कंफ्यूजन नहीं चाहिए। AC is acceleration of C and AR is centripetal acceleration or radial acceleration, right, which is 18, right. Now instead of doing all this calculation, directly remember the result. यहाँ पे कैलकुलेशन करेंगे, लेकिन याद में लास्ट में रिजल्ट याद रखना, बहुत बार क्वेश्चन पूछा, हॉट टॉपिक है, राइट। इंस्टेंट सेंटर का एक्सेलरेशन क्या होता है, व्हाट इज द एक्सेलरेशन ऑफ इंस्टेंट सेंटर, राइट। देयरफॉर नाउ इफ आई वांट टू फाइंड एक्सेलरेशन ऑफ सी पॉइंट, नाउ with respect to A, C is at south extreme point, C is south extreme point. See, if I draw a diagram here, point A is a center which is moving with acceleration of A towards right, which is nothing but 20 meter per second square. And with respect to A, C point is the bottom point, right, which is nothing but point of contact between ground and wheel. C is a point of contact between ground and wheel, right. Now, and wheel is rotating in clockwise direction with angular acceleration alpha, angular velocity omega, clockwise direction, right. Now this C will be having acceleration of A as it is. At C there will be acceleration of A as it is, which is nothing but 20 meter per second square, and there will be a centripetal acceleration or radial acceleration, which is nothing but towards center along radius. This centripetal acceleration or radial acceleration is towards center along radius. Therefore, there will be a AR. AR is nothing but radial acceleration or centripetal acceleration towards center along radius, which is nothing but 18. We have calculated centripetal acceleration. We have calculated 18. Right now, and there will be a tangential acceleration in the direction of rotation. तो देखो point C, tangential is nothing but perpendicular to radius, and rotation, this point C, can you imagine here, point C with respect to A is going backward direction, is going in backward direction like this because of clockwise rotation. Therefore, with respect to A, perpendicular to radius, there will be a tangential acceleration AT going towards left, which is nothing but 20 meter per second square. AT is 20 meter per second square. Therefore, if I observe point C, see, for this point C, that is instant center, there will be a acceleration of A towards right, which is nothing but 20. There will be a centripetal acceleration or radial acceleration, centripetal acceleration or radial acceleration towards center along radius, which is 18. And there will be a tangential acceleration towards left, which is 20. Now, my dear students, can you imagine here that acceleration of A and acceleration, tangential acceleration will get cancelled? They will cancel each other. Acceleration of A and tangential acceleration will cancel each other because they are equal in magnitude but opposite in nature. Therefore, they get cancelled. Therefore, at instant center, there is only acceleration, which is nothing but radial or centripetal acceleration. So, my dear students, very important note I am going to dictate here. For instant center, velocity is 0. Here you can see. For instant center, velocity is 0, but acceleration is, total acceleration is radial acceleration. For instant center, velocity is 0, but total acceleration is radial acceleration. Very important note. Remember this note. बहुत बार क्वेश्चन पूछा है, पूछेंगे और भी बाकी कॉम्पिटिटिव एग्जाम में, राइट। नाउ लेट अस गो फॉर अनदर पॉइंट. After instant center, go for point D. We are going to solve acceleration of point D, right? Here, note down this. If any doubt, please comment. My dear students, if any doubt, please comment. Now, if no doubt, we will go forward. We will move forward. Here we have seen tangential acceleration is 20, meter per second square. Radial acceleration, which is also called centripetal acceleration, is nothing but 18 meter per second square. Right. Now let us find point D. Let us find for point D. कोई भी डाउट होगा तो कमेंट में लिखो बच्चों. Let us find for point D. Here, point D. Right. Now, my dear students, the point D will be having acceleration of center point plus tangential acceleration plus centripetal acceleration. The point D will be having acceleration of center point plus tangential acceleration plus centripetal acceleration. So, with respect to A, see my dear students, in diagram, A is the center point. A is the center point. Right. Now, A is moving towards right with acceleration of A, which is nothing but 20 meter per second square. Right. With respect to A, the D point is towards west side, that is left extreme point is a point D. Left extreme point is a point D. Therefore, this point D will be having acceleration of A as it is. This point D will be having acceleration of A as it is. Right. Which is nothing but acceleration of A, which is nothing but 20 meter per second square, as it is with same direction. Direction भी change नहीं होगा. As well as D will be having tangential acceleration. Right. Now, tangential acceleration will be tangent at this point. See, tangent, I will draw first tangent. This is a tangent. But the direction of rotation of this tangent is clockwise, like this. It is rotating in clockwise direction, like this. Right. Therefore, with respect to A, this point D will go in upward direction. With respect to A, point D will go in upward direction. Can you imagine here? Therefore, the tangential acceleration, which is perpendicular to radius, will go in upward direction like this. There will be a tangential acceleration perpendicular to radius, AT, which is number 20 meter per second square. Right. And radial acceleration is towards center along radius. Right. Radial acceleration is towards center along radius. Therefore, radial acceleration will be, or centripetal acceleration, also called centripetal acceleration, towards center along radius. Right. This AC is 18. Is 18. Therefore, if I look at point D, if I see for point D, the point D will look like this. Here, point D. Here, point D is going towards right. Point D is going towards right with the acceleration of A, which is 20. Also going towards right with a centripetal acceleration, which is the limit 18, and going in upward direction with tangential acceleration of 20. Right. हेलो प्रिया, हेलो श्वेता, कौन सा नहीं आ रहा? Which one? Which point? कौन सा point नहीं समझ में आ रहा? Acceleration of D या कौन सा? आ गया. ओके ओके, तो चलो आगे बढ़ते हैं. राइट, लेट अस मूव फॉरवर्ड. तो नाउ सी हियर, तो here you can see D point is moving towards right with acceleration, centripetal acceleration as well as a acceleration of A. So एक ही डायरेक्शन में चल रहा है. They are moving in same direction. They will get added, and there will be a tangential acceleration of 20 magnitude in upward direction. Therefore, 20 plus 18, AA will get added in AC. Right. हेलो श्वेता. हाँ, B का देखेंगे. B का बताऊंगा फिर से. At the end, B का बताऊंगा, मुझे याद करके दो सिर्फ. Right. Concentrate on point D now. Now, 18 and 20 will get added here. you can see this centripetal acceleration and acceleration of center point will get added because they are moving in same direction, and there is a tangential acceleration of 20 magnitude, right? Therefore D point, for point D, this 18 will get added in 20, will become 38 towards right, and there will be 20 magnitude in upward direction, 20 magnitude in upward direction. So they are perpendicular to each other, they are perpendicular to each other. Therefore their resultant will lie between them like this. The resultant will go like this. That is acceleration of D point, acceleration of D point. Therefore we can say acceleration of D, acceleration of D will be equal to under root of 20 square plus 38 square, which is meter per second square, which is meter per second square. Okay, solve this, solve this. Whatever may be the answer, I don't have calculator, you have to solve this. Okay, okay, don't worry Shweta, at the end of lecture we will see point B again. I will explain point B. Now concentrate on point E. बाकी कोई डाउट है? Okay, चलो point E. After point D, let us jump on क्या है ये? लास्ट विश गेमर, क्या कमेंट है? चलो गो फॉर पॉइंट ई. नाउ फॉर पॉइंट ई, now see point E, for point E, that is acceleration of E will be equal to acceleration of center point plus tangential acceleration plus centripetal acceleration, right? That we have seen. Now let us jump for point E. See, A is the center point, A is the center point. This center point is moving towards right with acceleration of A, which is nothing but 20 meter per second square, right? And with respect to A, the north extreme point is point E. The north extreme point is point E, right? Therefore, this point E will be having acceleration of A as it is, plus there is a tangential acceleration and centripetal acceleration. Now, let us draw this. This point E will be having acceleration of A as it is, which is nothing but acceleration of A is going towards right of magnitude 20 meter per second square, right? Now there will be a tangential acceleration, there will be a tangential acceleration, and tangential acceleration is 20 meter per second square. Tangential acceleration is perpendicular to radius, it is tangent. We have to draw tangent at point E, and tangent to the circle is always perpendicular to radius. Therefore, and the direction of rotation, the direction of rotation of the wheel is clockwise, see, with angular velocity omega and angular acceleration alpha. Therefore this point E is moving in clockwise direction, like this, right? Therefore with respect to A, can you imagine this point E is moving in right side with respect to A, the point E is moving in right side. Therefore tangential acceleration will be like this. Tangent is nothing but perpendicular to radius, perpendicular to radius. This tangential acceleration is 20 meter per second square, having magnitude 20 meter per second square. Already we have calculated. And centripetal acceleration is towards center along radius. AC, last acceleration is AC. The centripetal acceleration is towards center along radius, right? Therefore plot this towards center along radius, AC, and centripetal acceleration is of magnitude 18. Therefore if I see point E, see for point E there will be a towards right, there is tangential acceleration of 20 magnitude as well as acceleration of A of 20 magnitude. And in downward direction, there is a centripetal acceleration AC of 18 magnitude. Therefore, can you imagine here? This tangential acceleration will get added in acceleration of A. They are moving in same direction, na? Therefore, they will get added. Therefore, for point E, if I add this, see for point E, let us solve for point E. Here, this will be the point E, which is moving in right side with 80 plus A, which is 20 plus 20 of 40 magnitude, and in downward direction of 18 magnitude, and they are mutually perpendicular. Therefore, resultant of these two will lie between them. The resultant of these two will lie between them, which is nothing but acceleration of E, which is nothing but under root of 40 square plus 18 square, right, meter per second square. This will be the acceleration of point E. Okay. Hello, Shweta. Have you seen this lecture from beginning? This is important because in the beginning I have explained this. Have you seen this lecture from beginning? And also here I am assuming that you have already seen recorded lectures. Here we are solving only theory questions. And then how you will understand? Sweta, in between you are not going to, no one is going to understand these concepts. You have to watch all the lectures from beginning, then only you will understand acceleration analysis. तभी तो मैंने स्टार्ट ऑफ लेक्चर में ही एक्सप्लेन किया ना एक्सेलरेशन एनालिसिस को. देखो डायनेमिक्स में, इन डायनेमिक्स वेलोसिटी एनालिसिस एंड एक्सेलरेशन एनालिसिस एंड जब टॉर्क एनालिसिस आएगा, दैट इज मास मोमेंट ऑफ इनर्शिया, बाद में आने वाला है मास मोमेंट ऑफ इनर्शिया. These 3 points you must see each and every lecture from the beginning. Okay, chalo, let us solve for any other point. My dear students, now concentrate. Here I am explaining quickly. Now concentrate. Right, there is a wheel, तो कोई अदर पॉइंट लेते हैं, व्हील के ऊपर अनदर पॉइंट को निकालते हैं. देयर इज अ व्हील, राइट, हैविंग रेडियस r, center point is a, radius of wheel is given 2 meter, right, angular velocity of wheel is given 3 rad per second, then angular acceleration of wheel is 10, angular acceleration of wheel is given 10 rad per second square, right. Acceleration of center point is always radius of wheel into alpha. Acceleration of center point is always radius of wheel into alpha, which is nothing but 2 into 10, which is nothing but 20 meter per second square. This is acceleration of center point, right. Now this wheel is rotating on ground, rolling on ground. This is a ground, right. And if I want to find acceleration of any point, let us find for any other. यहाँ पे मैं कोई भी एक पॉइंट ले रहा हूं, उसका निकालेंगे, राइट. लेट अस से इफ आई कंसीडर पॉइंट P. माय डियर स्टूडेंट्स, कॉन्सेंट्रेट. फिर से मैं रिपीट कर रहा हूं ये. इफ आई कंसीडर पॉइंट P at some angle with horizontal, let us say with horizontal at angle 30 degree, with horizontal. If I want to find acceleration of point P, right, this acceleration of point P will be having for any point on the wheel. For what I am saying, for any point, you can consider infinite points. for any point on the wheel, the acceleration is nothing but acceleration of center point plus acceleration of that point with respect to center point, right? That is, it is a acceleration of center point, and here APA is nothing but acceleration of P with respect to A. Acceleration of P with respect to A. And acceleration of point P with respect to center point is having two components. That is, first component is tangential acceleration and second component is centripetal acceleration. Acceleration of any point with respect to center point is having two components. That is, first is tangential acceleration, other is centripetal acceleration. And my dear students, this tangential acceleration is tangent. Tangent is nothing but perpendicular to radius in the direction of rotation, right? Tangential acceleration is tangential in the direction of rotation, in the direction of rotation, right? This is tangential acceleration. And the magnitude of tangential acceleration is, if I want to find magnitude of tangential acceleration, my dear students, here I am erasing this, right? Acceleration of any point with respect to center point is nothing but tangential acceleration plus centripetal acceleration, right? This AT is tangential and having magnitude of, that is RAP, the distance of point P from A into alpha, right? This is the tangential acceleration, R alpha. That is distance of point P from A into alpha. This is tangential acceleration in the direction of tangent. And centripetal acceleration, AC is centripetal acceleration or radial acceleration. It is towards center along radius. Towards center along radius. Along radius. And magnitude of AC is distance of center point from point P. Distance of point P from center point into omega square. R omega square. We can say RAP omega square. This is how we are going to calculate. All right. There, this is acceleration of point P with respect to point A. Right. Therefore, once you calculate this, we can say that, see here, acceleration of point P is equal to acceleration of point A. Acceleration of point P is acceleration of center point plus acceleration of point P with respect to center point, which is nothing but acceleration of point P is equal to acceleration of center point, that is A point, plus tangential acceleration plus centripetal acceleration. And my dear students, this is a vector addition. This is a vector addition. And vector addition follows law of parallelogram. That is, let us say there is a vector F1, or let us say vector A, and there is a vector B. These are the two vectors. Having inclination between them is theta, having angle between them is theta. The resultant of these two vectors, that is resultant vector is equal to vector A plus vector B. This magnitude of resultant is calculated as under root of A square plus B square plus twice AB cos theta. This is how magnitude of resultant is calculated, right? As per this law, we are going to calculate, right? Now let us find for point P. अब तो समझ में आया ना? And AT क्या होता है? RAP alpha, and AC is RAP omega square, and acceleration of A is radius of wheel into alpha. Acceleration of A, center point, acceleration of center point is radius of wheel into angular acceleration. But tangential acceleration is distance of center point from that point. अब यहाँ पे तो circumference पे है, RAP radius ही बन गया है, यहाँ पे तो RAP is equal to radius of wheel बन गया. लेकिन पॉइंट पी कहाँ पे भी हो सकता है ना, ये अंदर हो सकता है पॉइंट पी, ये अंदर हो सकता है पॉइंट पी, ये बाहर हो सकता है पॉइंट पी. पॉइंट पी कैन बी एट एनी लोकेशन. सो जब टेंजेंशियल एक्सेलरेशन निकालो तब आपको while calculating tangential acceleration you have to consider radius of that point from center point, and while calculating centripetal acceleration you have to consider radius of that point from center point, right? Now let us calculate for point P. यहां तक तो हो गया. Now concentrate. Go to calculate for point P. Right. Now there is a wheel. This is a wheel. Right. Now here center A is moving. Let us say center A and point P will be here at 30 degree. At 30 degree, this is the point P. Right. And let us say wheel is, there is a ground. There is a ground. Right. Here you will find ground. Right. And wheel is rotating in clockwise direction with angular acceleration alpha, angular velocity omega. So my dear students, definitely because of this clockwise rotation, definitely A point will move in forward direction. After some time, the wheel will achieve new location like this. After some time, wheel will achieve new location. Means A is moving towards right. We can say the point A is moving towards right with acceleration of A. With acceleration of A, definitely we can say, right, with acceleration of A, which is nothing but we have calculated radius of wheel into alpha, that we have calculated. Radius of wheel question में दे रखा है 2, alpha दे 10. Acceleration of center point is, radius of wheel is 2, x alpha is 10, which is nothing but 20 meter per second square. This is acceleration of center point. Right. Now let us understand again. तो एक तो बात पता चली, A is moving towards right. Now here there is a ground. A is moving towards right. That we have understood with 20 meter per second square. Right. Now acceleration of P is nothing but acceleration of A as it is plus tangential acceleration plus centripetal acceleration. Right. Now therefore acceleration of P will be having acceleration of A as it is. Here you will see as it is. That is acceleration of A is equal to 20 meter per second square. As well as there is tangential acceleration. Let us find this tangential acceleration. This AT is nothing but RAP into alpha. Now distance between A to P is radius of wheel. Distance between A to P is radius of wheel into alpha. अब point P कहीं पे भी हो सकता है, अंदर भी हो सकता है. Accordingly, we have to consider which is nothing but tangential acceleration is equal to radius of wheel is 2, alpha is 2, 10, which is nothing but 20 meter per second square, and it is tangential. It is tangential at that point P. At the point P. तो point P पे my dear students tangent draw करो. तो point P पे tangent like this. There will be we have to draw tangent at point P. And my dear students, this tangent is always perpendicular to radius. Tangent is always perpendicular to AP, that is radius. Right. Therefore, and this wheel is rotating in clockwise direction. Means with respect to A, can you imagine point P is going in downward direction? Because of rotation, with respect to A, the point P is going in downward direction. तो tangential direction में AT दिखाना है आपको in downward direction. Therefore, there will be AT in downward direction like this. In downward direction like this. Because of clockwise rotation, P is going in downward direction with respect to A with tangential acceleration. AT is equal to 20 meter per second square. Right. Here we have calculated. As well as there is centripetal acceleration. And centripetal acceleration is towards center along radius. So let us find centripetal acceleration. This AC is nothing but distance between A and P omega square. ये हो गया centripetal acceleration. 12th में भी पढ़ा है बच्चों आपने ये. Right. Therefore, distance between A to P is radius of wheel. Therefore, R omega square. Therefore, AC is equal to radius of wheel is 2. Omega angular velocity is, देखो angular velocity क्वेश्चन में दे रखा था. You can see here angular velocity is 3 rad per second. क्वेश्चन में ऑलरेडी दे रखा था. Right. In question, angular velocity is given, my dear students, 3 rad per second. So use this angular velocity, which is nothing but 3 rad per second, right? Therefore, here you can say angular velocity is 3 rad per second. Therefore, 3 square, right? Therefore, 2 into 3 square, 2 into 9, 18. It is 18 meter per second square. And this centripetal acceleration is towards center along radius. Towards center along radius. Along radius. ये हमेशा डायरेक्शन होता है इसका. Centripetal acceleration is towards center along radius. तो बच्चों centripetal acceleration जो आएगा from P A की तरफ चला जाएगा. From P it will go towards A. AC is equal to 18 meter per second square towards center along radius, right? तो ये बन गए accelerations, right? Now अब एंगल निकालते हैं. अब 3 वेक्टर है आपके पास, तीनों की एडिशन करनी है. नाउ लेट अस फाइंड द एंगल्स. लेट अस फाइंड द एंगल्स. सी एपी को अगर मैं एक्सटेंड करता हूं, इफ आई एक्सटेंड एपी, द एंगल ऑफ एपी विथ हॉरिजॉन्टल इज 30 डिग्री. देयरफॉर एंगल ऑफ एपी विथ हॉरिजॉन्टल विल बी 30 डिग्री. Therefore, this angle will remain 60 degree. This angle will remain. Angle between acceleration of A and tangential acceleration, this angle will remain 60 degree. Definitely, my dear students. 100% पक्का होगा कि नहीं? 100% होगा. No doubt about that. Right. Because AP is perpendicular to AT. AP, that is distance center to P. This radius is perpendicular to tangential acceleration. तो ये 60 आएगा. Simple mathematics से ये आना चाहिए. Right. Simple mathematics से ये आना चाहिए. Right. तो अब समझते हैं क्वेश्चन को. सॉल्व करते हैं इसको. Now, what I got, if I consider point P, let us consider point P. Now, for this point P, there is an acceleration of A going towards right of 20 magnitude, right? Then there is a tangential acceleration like this at 60 degree of 20 magnitude at 60 degree from horizontal, and there is radial acceleration towards center. Radial acceleration is also called centripetal acceleration. AC towards center of 18 magnitude, and tangential acceleration and radial acceleration, that is tangential acceleration and centripetal acceleration, are always perpendicular to each other. Means this angle is 90 degree. Angle between AC and AT is always 90 degree of magnitude 18. बस दोस्तों इन दोनों, अब इन तीनों की सिर्फ एडिशन करनी है आपको. इन तीनों की वेक्टर एडिशन करनी है. चलो वेक्टर एडिशन करते हैं इनकी. राइट माय डियर स्टूडेंट्स, नाउ रिजॉल्व दीज वेक्टर्स अलोंग एनी टू लाइंस. इन तीनों वेक्टर को कोई किसी भी दो लाइन में रिजॉल्व करते हैं. चलो कंसीडर करेंगे. लेट अस से हियर पॉइंट P, there will be a AC of magnitude 18, there will be a AT of magnitude 20. इन दोनों के बीच में परपेंडिकुलर एंगल है 90 डिग्री. Therefore, resolve acceleration of A in the direction of AC and AT. This acceleration of A, which is nothing but 20 at angle 60 degree, I am going to resolve this along AT and AC. दो कंपोनेंट ले लो इसके. Therefore, जहां से एंगल दे रखा होता है, there will be a cos component. Therefore, along AT, this AA will be having cos component. Acceleration of A cos theta, cos 60, and perpendicular to along AC, there will be a sine component, that is AA sine 60. Right. Therefore, now simply, can you imagine here, this AC and AA sine 60 are in line. Here AC and AA sine 60 are in line. Here this AC and AA sine 60 are in line. Therefore, directly they will get added. Right. Therefore, the x for point P, added means subtract होगा ना. In line है, opposite direction में है, तो subtract होगा. Therefore, there will be a here in this direction, the net resultant along this direction will be 18 minus AA. AA is nothing but 20 sin 60. AA is given 20. 18 minus 20 sin 60 इस डायरेक्शन में चला जाएगा. एंड उसके परपेंडिकुलर में, perpendicular to this, you can see here this 20 and AA cos 60 will get added. एक ही डायरेक्शन में है ना दोनों, both are in same direction, and AA cos 60 is nothing but AA is 20 cos 60, therefore they will get added. इन दोनों की एडिशन होगी, therefore in this direction 20 plus 20 cos 60, and these directions are perpendicular to each other, mutually perpendicular to each other, therefore angle between them is 90 degree. Therefore resultant of this point P, the resultant acceleration of point P will be somewhere in between them, that is acceleration of point P. अब इन दोनों का रिजल्टेंट निकालना है. To find resultant of these two, acceleration of point P will be equal to under root of we can say 18 minus 20 sin 60 whole square plus अंडर रूट में आएगा 20 plus 20 cos 60 whole square meter per second square. This is how we are going to find acceleration of any point on the wheel. अगर कोई स्टूडेंट इन बिटवीन लेक्चर से आया है तो उसको समझ में नहीं आएगा. स्टार्ट से लेक्चर को देखो, सब कुछ समझ में आएगा. बिकॉज इन इंजीनियरिंग मैकेनिक्स दिस इज वेरी क्रिटिकल कंसेप्ट. Finding velocity of any point on the rolling wheel, finding acceleration of any point on the rolling wheel, as well as solving the problems of mass moment of inertia. These are very critical top bits and also hot topics for the GATE examination. बहुत बार क्वेश्चन पूछते हैं इनके ऊपर. तो बच्चों इनको लेक्चर बिगिनिंग से सॉल्व करो, बिगिनिंग से लेक्चर को देखा करो ऐसे लेक्चर के लिए, राइट. एंड here in these live lectures, I am assuming you have already seen all the recorded lectures from Ekeeda application, and here you are only to practice the previous year GATE questions, right? This is my assumption, right? And my dear students, at the end, let me promote Ekeeda. Now, if you subscribe Ekeeda, if you take any course from the Ekeeda, and if you use WADNE 10, this promo code, use this promo code WADNE 10, then you will get 10% discount for your fees for any course. And already you know that Ekeeda is the largest online learning platform for engineering students. And this year Ekeeda is launching GATE examination also. In this course, you are getting all the recorded lectures in Ekeeda app. This Ekeeda app you will find on Play Store. Plus, you are getting live lectures on YouTube like today, आज के जैसा live lecture. Plus, you are getting test series. In the same, you are getting test series. Plus, you are getting handwritten notes of each and every faculty. Handwritten notes of faculties. And this course, in launching phase, they are offering you only for 7,500 rupees. Total course for each and every subject they are offering for this much less price. And again, in this price, if you use WADNE 10, this promo code, you will get 750 discount. 750 rupees discount, that is 10% discount. Means ultimately the cost will be less than 7,000. The cost is less than, your cost is less than 7,000. 7K is more than your fees, right? Okay, if anybody having doubt, please let me know. Here I am live for next 2 minutes. If anybody having doubt, please comment. Otherwise, you can say bye. चलो हो गया होगा किसी का, तो बाय करके निकल जाओ. किसी को डाउट है तो कमेंट में लिखो वैसे. ओके चलो. बंगरी राज बाय. बंगरी बाय. I am waiting for your doubts. I am live for next 2 minutes. स्क्रू जैक. अरे स्क्रू जैक यहाँ कहाँ आएगा, मशीन डिजाइन में आएगा ना वो. बंगरी, स्क्रू जैक मशीन डिजाइन में आएगा. वहां पे आपको निकालना होता है टॉर्क रिक्वायर्ड टू लिफ्ट एनी व्हीकल, देन लीड पिच कैलकुलेशंस, effort required, power required. These are all calculations you are doing in screw jack. कौन सी एग्जाम है भाई? यूनिवर्सिटी एग्जाम है या एकीडा की है? फर्स्ट ईयर. अरे गेट यहाँ पे तूने फर्स्ट ईयर का थोड़ी ना क्लास लगाया, गेट का क्लास लगाया ना. गेट के सिलेबस में नहीं है वो. गेट के सिलेबस में वो आएगा मशीन डिजाइन में. फिर भी पढ़ो, लेकिन सिंपल सा है. फ्रिक्शन का कंसेप्ट यूज होता है वहां पे स्क्रू जैक में. फ्रिक्शन का कंसेप्ट यूज होगा आपको. सिंपल सा कंसेप्ट है, हो जाएगा आराम से. ओके चलो बाय बाय. बाय बाय एवरीवन.